in this series, you can see in this series we need to find f dash of a, f double dash of a, then here fn of a factorial n. So that's why what we're going to do here, just wait. So what we're going to do here, first let us find f of a. F of a means here f of 1, right? F of 1 going to be 1 plus 1, that's going to be 1 by 2, right? So now let us find f of z, sorry, first order derivative of z. If you differentiate it, right, so it can be written as d dz of z plus 1 whole to the power minus 1. This is nothing but 1 by z plus 1, right? So hope you have understood this. So if you differentiate it, then it's going to be minus 1 by minus 1 into z plus 1 whole to the power minus 2. That means you can write this way, minus 1 by z plus 1 whole square, right? So if once we have got f dash of z, so we can find f dash of a, right? So f dash of a means here f dash of a means we can find f dash of 1, because we are to find about 1, right? So this is going to be equal to minus 1 by 1 plus 1 whole square. So that's why it's going to be equal to minus 1 by 4, right? That's going to be equal to minus 1 by 4. Now let us find second order derivative of f of z. So if you differentiate it again, then what you're going to have, then it's going to be, so here you can see minus 1 into z plus 1 whole square. If you differentiate it, so it can be written minus 2, right? This can be written this way, okay? If you differentiate it again with respect to z, then what you're going to have, then you're going to have minus 1 into minus 2, that's going to be plus 2, z plus 1 minus 2 minus 1, that's going to be minus 3, right? Minus 2 minus 1, that's going to be minus 3, which can be written as z plus 1 whole to the power 3, right? So hope you have understood this. So we have got f double dash of z is this, right? So this is what we have got. Now therefore f double dash of a means here f double dash of 1, that's going to be equal to 2 by 1 plus 1 whole to the power 3, that means 2 cube. So that's going to be 8, right? That's going to be 8. So similarly we can find f triple dash as well, f triple dash of z. So if you differentiate this again, that's going to be minus 6 by z plus 1 whole to the power 3 plus 1, that's going to be 4, right? So that's what we're going to get. So now you can differentiate yourself. I think you know derivative, okay? So now here you see, so therefore f triple dash of a, that means f triple dash, here a is equal to 1, so that's going to be equal to, if you put 1 here, then you're going to have 2 to the power 4, that's going to be minus 6, and 2 to the power 4 means 16, okay? If you cancel these things, then you're going to have so here let me tell you one more thing, you can cancel this one as well. 2 1s are 2, 2 4s are 8, so that's going to be 1 by 4, right? And so this is going to be 3 by 8, so minus 3 by 8, that's what we're going to have. So hope you have understood this. So similarly we can fourth order derivative of f at a, right? So on, okay? So what going to be the Taylor series now? So now let me copy all these things and let me go to the next slide, okay? Because we have not enough space here. So here is the next new slide. So I have copied all these things. So in Taylor series, so in Taylor's series, so what we're going to get in Taylor series, f dash of z about z is equal to a, we can express this way, right, as you can see here. So that's why. So now here f of z is nothing but 1 by z plus 1. So let me replace this one by 1 by z plus 1. So what is f of a here? F of a that we have already got here. Here you can see this is f of a, this is equal to half. So let's put half here, half plus, and then z minus a is 1 here, a is 1, so that is z minus a. Instead of a, we're going to put 1 here into f dash of a. F dash of a here, this is the value minus 1 by 4. So what we can write here, so we can make it negative and we can write here by 4, right? Then here we have this, so this is nothing but, here you can see this one is this one, so that is again 1 by 4. So what you're gonna get here, first let me write this one, z minus a, instead of a we're gonna have 1 whole square, and f of a is nothing but here a second order derivative of f at z is equal to a is nothing but 1 by 4 here in this case. So we're going to put here 1 by 4, then here factorial 2 means 2 into 1, that is 2 simply. So it's going to be this. So similarly we're going to get z minus 1 whole to the power 3, then after this next term going to be third order derivative at z is equal to a, right, by factorial 3 into z minus 1, z minus a whole to the power 3. So here z minus a is nothing but z minus 1 and whole to the power 3, and value of f triple dash a, that's going to be this one, minus 3 by 8, and by factorial 3. So this is factorial 3. Factorial 3 means you can write 3 into 2 into 1, that is simply 3 into 2, right? So that's what we have got. So now let me clean these things. So hope you have noted these things, the upper part. Let me clean these things, okay? And now let me scroll it, just wait. So this is what we have got now. So it can be written this way, 1 by z plus 1, so 1 by 2 minus z minus 1 by 4, then plus z minus 1 whole square by if you multiply these two, then it's going to be 8, then again minus, because there is minus, this is plus, so minus we have got. So z minus 1 whole cube divided by here these three cancel, so we have got here 16, right, and plus and dot 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 so on. So this is the required series. So this is our answer. So hope you have understood this. Now let's move on to the next question. So pause the video and note these things, okay? So this is the last part, and the first part was this, right? So right, so now let me solve question number 2. So let me cut this question, let me cut this part, okay? We don't need this, just wait. So let me cut this thing, okay? So this is question number 2. This is the function, and we need to find its value. We need to express this in Taylor expansion in these 2 points, about these 2 points, about z is equal to 0 and about z is equal to 1, okay? So now first let us solve. So what is the function here? F of z is equal to z minus 1, right, and by z plus 1, that's what we have got, right? So first of all, as we're gonna need f dash z, f double dash z, let me find those things, because after that we're gonna find f dash at z is equal to a, f dash at z is equal to f double dash at z is equal to a, and so on, right? So here a gonna be, for this case a gonna be equal to 0, and for this case a gonna be equal to 1. So that's two different cases. We are not going to differentiate separately because derivatives will be same, but value of a gonna be different. So that's why first let me find the derivatives of f of z, first order, second order, third order derivatives, and so on. Okay, so then we're gonna deal with the Taylor series. Okay, so now let me find f dash of z. Okay, so just wait. First order derivative of f of z. Okay, so here what we're going to do, we're going to use the u by v rule. Derivative of u by v is nothing but v derivative of u minus u derivative of v by v square. Let's use that one. So if we use that one, then what we're going to have, so let me keep it, put it aside here. Okay, so it is going to use z plus 1. If you differentiate z minus 1, if you differentiate z minus 1, then derivative of z, that's going to be 1, derivative of 1, that's going to be 0, right? So simply we have got 1, right? Simply we have got 1. So this is into 1. So that's why we can write z plus 1. So simply we can write z plus 1. Then minus. Then u into v dash, that means numerator is z minus 1, then derivative of denominator is z plus 1. And if you differentiate this with respect to z, that's going to be again 1. So we can write here simply z minus 1 into 1, that means z minus 1. And if you remove this bracket, then this minus going to be plus here, this is going to be plus 1, right? So minus z plus z cancel, we have got plus 1 and plus 1. Just wait, let me write this one clearly, plus 1 by denominator square, that is z plus 1 whole square. That's what we have got. So 1 plus 1 is 2 by z plus 1 whole square. That's what we have got, right? Now how to find the second order derivative of f of z? So here what we're going to do, we're going to find derivative of second order second order derivative of f of z. So this can be written as 2 into z plus whole square minus z plus 1 whole to the power minus 2. That's what we can write. So if you understood it, so now if you differentiate it, then what it's gonna be, minus 4 z plus 1 whole to the power minus 3, and this can be written in this way, right? So minus 4 by z plus 1, sorry, not 1, yes, 1 whole to the power 3, right? We can write this way. Okay, now if you differentiate again f triple dash z, so as we can write this one in this way, minus 4 into z plus 1 whole to the power minus 3. And if you differentiate it again, with respect to z, that's going to be equal to minus 4 into minus 3, that's going to be plus 12, and into z plus 1 whole to the power minus 4, right? So which can be written this way, 12 by z plus 1 whole to the power 4, and so on, right? So that's what we're going to have. So hope you have understood this, right? So first let us deal with about z is equal to 0. Okay, so about z is equal to 0. About z is equal to 0, and 0 is the value of a here. So now you see f of z is here z minus 1 by z plus 1, therefore f of a, that's going to be f of 0 here in this case, that's going to be equal to 0 minus 1 by 0 plus 1, that's going to be minus 1, right? Minus 1 by plus 1, that means minus 1. As you can see, f dash z is equal to what we have got, this one, right? 2 by z plus 1 whole square, right? So f dash of a, that means here 0, a is 0 here, that's gonna be here z gonna be replaced by 0, so is gonna be equal to 2 by 0 plus 1 whole square means 2 by 1 square, that's gonna be equal to 2, so that's gonna be equal to 2. Now let us find f double dash at z is equal to 0, so just replace this one by 0 here, so then what it's gonna be, so minus 4 by 1, that's gonna be minus 4, right? And let us find f triple dash at z equal to 0. Here if you put 0 here, then it's gonna be 12, right? And so on, right? So what gonna be the Taylor expansion here? What gonna be the Taylor series? So here you see, so let me rearrange these things a little bit more, just let me push it up. So let me write this value here, and this values here, use comma, and this one here. Okay, so Taylor series, so that is given by, just wait. So now here you can see f dash z is nothing but here z minus 1 by z plus 1, and f of s, a means here f of 0, but we have got f of 0 is equal to minus 1, so here we can write minus 1, let's write here minus 1. Then here we have z minus a is 0, a is 0 here, so we're gonna write z only, and f dash of a, so where is the value here, this one, this is f dash of a, so a is 0 here, so that's gonna be 2, so that's why here we have got plus 2 into z, so here we have put 0, a equal to 0, right? Similarly, what gonna be second order derivative of f at a, so this is a is 0, so that's gonna be the second order derivative, so it is minus 4 by factorial 2 means 2 into 1, and this is going to be z square, right? That's what we're going to have, so this is minus, so that is what we're going to have. So if you cancel these two, then it's going to be equal to minus 2 z square, so let me write here minus 2 z square, right? So it's going to be minus 2 z square. So similarly we're gonna have after this term we're gonna have third order derivative of f at a divided by factorial 3 into z minus a whole cube, right? So here is third order derivative of f at a is equal to 0, that's going to be 12, right? And here it's going to be 0, z minus 0 and whole cube, that's going to be the z cube, and divided by factorial 3. Factorial 3 is nothing but 3 into 2 into 1, so let me cut it. So here it's going to be 3 into 2 into 1, right? 3 into 2 into 1, and that's going to be equal to 3 to the 6, 6 to the 12, so here it's going to be 2z cube, right? So if you calculate this, then it's going to be equal to 2z cube, that's what we're going to have, and plus dot 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 so on, right? So here you see we can write this as minus 1, and we can take the 2 common from each term, right? So if you follow this pattern, next term going to be equal to minus that next term going to be minus 2 into z to the power 4, then next term going to be plus 2 into z to the power 5, and so on, right? So that's why, so here dot 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 we can take the 2 common, z minus z square plus z cube, and again minus z to the power 4, and plus dot 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 so on. So this is our answer. That's how we can find find the Taylor series of this given function about z is equal to 0. Now let's find about z is equal to 1. So here you see, let me copy these things, because we don't need to repeat these things if once already written, because we are going to find the value of same function. We're going to express the same function in Taylor series about two different points. So that's why, as we have already got those differential derivatives of the function, first order, second order, third order derivatives, so we're gonna get the we're gonna use the same. Let's go to a new slide. So this is the given function. You don't need to repeat these things, okay? Just I have written those things because I have to use those results, so I don't want to go back the previous slide frequently, okay? So it's gonna be disturbing. So now about, we need to find z is equal to, about z is equal to 1, right? So then about z is equal to 1, what going to be the value of this function? So f of a, that means f here a is 1, so f of 1, that's going to be equal to 1 minus 1 by 1 plus 1, that's going to be 0, right? So if you put z is equal to 1, so that's why this is 0. Then what going to be, if you put here 0, sorry, not 0, 1, if you put here 1, z is equal to 1, then f dash of 1, that's going to be equal to, if you put here 1, so it's going to be 2 by 1 square, that's going to be 2 simply, right? Sorry, not 2, so it's going to be 2 by 1 plus 1 square means 2 by 2 square. If you cancel this 2, then it's going to be 1 by 2, right? So that's going to be 1 by 2. Then if you put here z is equal to 1, then what it's going to be, f double dash at z is equal to 1, its value going to be equal to minus 4 by 1 plus 1 whole cube, that's going to be minus 4 by 2 cube. 2 cube is nothing but 8, so if you cancel 8 by 4, then you're going to get 2, so you're going to get minus half, right? So here it's going to be equal to minus half. So let's find third order derivative of f at z is equal to 1. F z is equal to 1. If you replace this z by 1, then what you're going to have, so just wait, let me arrange little bit, just wait, give me a second, okay? So okay, so f triple dash of 1, that's going to be equal to, so if you put 1 here, then it's going to be 12 by 2 to the power 4, right? Sorry, it's going to be 2 to the power 4. 2 to the power 4 is nothing but 16, right? 2 to the power 4 is nothing but 16. When you have 12 by 16, then what it's going to be? So 4 3s are 12, 4 4s are 16, that's going to be 3 by 4, and so on. That's how we can find the values, right? So what's going to be the Taylor series now? So as we have got those values, so let me clean this part, okay? Because already written these things in the previous slide, so let me clean these things, okay? So let me pull these things out, okay? So here we go. So in Taylor series, so what was the series? Taylor series. So this is the Taylor series, right? Here you can see, and okay. So here we can replace this f of a by f of 1, right? Because we are to find about 1, and f of z. What was the f of z? F of z, in this case we have the given function z minus 1 by z plus 1. You can check if you have written. Let me go back to the previous slide. Here, this is the f of z, this is the given function, right? So then f dash a is here 1, z minus 1, then plus second order derivative at f, second order derivative of f at 1, z is equal to 1, here factorial 2 into z minus 1 whole to the power 2, and plus third order derivative of the function f at z is equal to 1 by factorial 3 into z minus 1 whole cube and dot 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 so on. That's what we're gonna have. So now let us replace these terms by the values that we have obtained here, right? So if we use those values, then what we're gonna have, then we're gonna have 0 plus, so f of 1 is 0 here, f of 1 is 0 plus then half into z minus 1, because f dash of 1 is half, this is f dash of 1, that is half, so half into z minus 1, then plus, you know, second order derivative of f at z is equal to 1 is minus half, so here we're gonna have minus half by factorial 2. Factorial 2 means 2 into 1 by z minus 1 whole square. That's what we're gonna have, right? So then you see in the next term, if you replace this by this value 3 by 4, then you're gonna get here, so here 3 by 4, and factorial 3 means nothing but 3 into 2 into 1, right? So let me write it properly. This is 3 by 4 and this is z minus 1 whole cube and plus dot dot dot. So here you see, so 1 by 2 z minus 1, so it's going to be minus, and 2 into 2, that's going to be 4, minus 1 by 4 into z minus 1 whole to the power 2, then plus here 3 going to be cancelled, then 4 into 2, that's going to be 8, right? 1 by 8 z minus 1 whole to the power 3, then plus dot 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 so on. So this is our answer. That's how we can solve. So hope you have understood this. So see you in the next video. Stay connected, share with your friends, subscribe to the channel, hit the thumbs up button. Okay, so see you in the next video. Bye bye.